What do you think you're doing?
I'm just throwing trash.
On the ground? Really?
Yeah, got a problem with that?
Yeah, of course. You're supposed to throw trash in its place.
Oh, please, what difference is it going to make? The world is already polluted anyways.
Any small deed can make a difference. I have an idea.
What?
Instead of throwing trash away, how about we make it into something useful? Plus, the trash that you have is organic.
What kind of useful things are made from trash?
We can make it into... Eco-enzymes. My mom makes it a lot in our house. It's an organic solution made from organic trashes, molasses, and water, with the measurement ratio of 1 to 3 to 10, which left to fertilize for about 3 months. Ever since my mom used it in our house, I have never encountered any kind of insects in our house.
Wow, that's so cool!
So, how about that? Are you interested in making it together?
Sure, let's do it!
When someone mentions environmental pollution, what comes first to mind? Well, it would either be plastic bags, food packaging, or metal cans. But has it ever come into consideration that there are also other types of trash that plays a big contribution in road pollution and other natural disasters such as flood and waste avalanches? The team are emphasizing on the uncommon organic waste surrounding humans' lives, such as the visible fruit skin and leftover vegetables that are disposed of by humans in large numbers per year. Therefore, the team finds a better solution to recycle those leftovers for a better cause. They call this product Eco-enzyme, a multi-purpose solution from organic products with a lot of benefits both for the environment and daily life use.
Even after knowing the whole process of making eco-enzyme, it would be impossible for all of this to produce eco-enzyme if it isn't for the influence of science, as well as several other subjects such as mathematics, art, and computer science in preparing all the data. Looking into biology, feasible fruit peels and leftover vegetables are organic waste, which can experience decomposition and break down into smaller, odorless materials or compost. But according to data from 2019, Indonesia produces 64 million tons of waste annually. With additional data from the Ministry of Environment and Forestry of Republic Indonesia, the composition of waste is mostly organic waste, which reaches 60% of the total waste. Talking about the environment, even the liquid solution of eco-enzyme itself is science, specifically from the chemistry vector. Whereas the solution will go through fermentation process for 3 months. Within that period of time, the solution will go through different phases until it's ready to be used. Each phase will produce a different chemical reaction, which would be alcohol in the first month, vinegar in the second month, and finally enzyme in the third month. During the fermentation process, glucose is broken down to produce pyruvic acid. Pyruvic acid, under anaerobic conditions, will undergo decomposition by pyruvate decarboxylase to become acetaldehyde.
Furthermore, acetaldehyde is converted by alcohol dehydrogenase into ethanol and carbon dioxide, where Acidobacter bacteria will convert alcohol into acetaldehyde and water, which then acetaldehyde will be converted into acetic acid. After fermenting the solution for 2 months, the team's solution is in the stage of producing vinegar or acetic acid, which they can prove by the result from the potential of hydrogen test pack, which results in the number 4, indicating that their ecoenzyme solution is a weak acid solution. In order to see if their hypothesis of a successful ecoenzyme solution is correct, the team will have to see the texture of the solution in the hopes of producing a water-like solution such as floor cleaner solutions. Therefore, by pouring the solution on an inclined plane, then roll some balls over the plane to see if the liquid solution produces a sticky and thick or slippery and thin texture. Later on, the team could find the coefficient of the friction it creates by finding the speed of the object when it reaches the end by using EMA equal EMB as the equation of the law of conservation energy. Since the team is finding the speed of the object after it has reached the end, the kinetic energy of A and the potential energy of B equals 0. They insert the mass, gravity, and height of A, then calculate. Then the team moves the half from B to A by multiplying it with the result of A's calculation. Lastly, square root the final calculation to find the speed of B. After that, the team proceeds to use W, or known as energy equaling the delta of the potential energy, to find how much energy is created when the object reaches the end.
To find the speed, the team uses the formula of speed powers of 2 equals to gravity times the height of A times 2. With the value of gravity as 10, the height used is 24 centimeters, but science's experiment uses a meter unit. It is divided by 100 to get 0.24 meters, multiplied by 2 and square at the root, resulting in 2.2 meters per second. Finally, to find energy with the formula of W equals delta potential energy, the team multiply mass, gravity, and height of A minus 0. With a mass of 25 grams, that equals to 0.25 kilograms, the value of gravity as 10, and height A as 0.24 meters, to get a result of 0.6 joules.
Aftermath of all this, mathematics plays a role in making exponential and/or logarithmic graphs, in which the team also include the equations and describe the characteristics of the graphs, resulting from the comparison of the amount of molasses with the resulting amount of weight of the ecoenzyme. Moving on to the artistic side, the team put a lot of effort into presenting elements of art in this project, especially during their workshop in early April, where they make activity posters that invite the junior high school students of St. Ursula, Jakarta to participate in their workshop about ecoenzymes. In this activity, the team distribute goodie bags to the participants, which they fill with 1 orange, 1 bottle of molasses, and an eye-catching ecoenzyme maker guide paper that they decorate themselves. All into a small cupboard box. They decorate it with their own handmade stickers as well as handmade thank you notes on top of the box. With that, the team is indirectly relating this material to computer science, where they create an Instagram account containing information about ecoenzymes, activity posters, and their workshop documentation. The team is aware that huge social media platforms such as Instagram are effective for disseminating information, so they take advantage of this, where the information the team convey can be spread to a wide audience and accessible by everyone without exception.
Molasses, fruit peels, and clean water are required to make ecoenzyme. The ingredients are prepared in a ratio of 1:10 according to the order above. The tools to make ecoenzyme are a measuring cup, a stirring spoon, a scale, and a container. The first thing to do is to clean the container with soap. After that, pour 1000 milliliters of clean water into the container and add 100 milliliters of molasses. Mix the water and the molasses by stirring it and add the remaining 300 grams of fruit peels. Last, close tightly and label the date of manufacture and harvest date. After 3 months, ecoenzymes can be harvested and can be used. Within 3 months, there are several signs that will appear if the ecoenzyme fails. The most common problems are the emergence of maggots in the container because the container is not tightly closed, and the appearance of a rodent smell and black mold. There are several characteristics if the ecoenzyme is successful. The color of the ecoenzyme will be bright brown and it smells of fresh sourness. Ecoenzymes have a lot of benefits. One of the benefits is to be floor cleaners. With the products that the team makes, the team decided to make a workshop for the students at St. Ursula Junior High School, Jakarta.
In conclusion to the team's experiment, ecoenzymes can be used as a multi-purpose organic tool for their daily household lives, and to add to that, the team also saves the earth by recycling organic waste that is created. The group thinks of this as an innovative way to help the earth. Not only are the team reducing the amount of waste the team produced by making it into something else, the team are also training their creative and survival skills by making ecoenzymes.
That's interesting, right?
Wow, I didn't know that ecoenzyme has so many benefits. From now on, I will keep the remaining skin of eating foods.
That's right. It's better if the waste is made into something more useful.
Plus, it's super easy to make.
The most interesting thing is that you can learn biology, physics, chemistry, and even math from ecoenzyme.
Yeah, but
What happened?
you know, I've always loved art. Is there anything related to art that I can do?
Of course, you can make an ecoenzyme kit and share it to your friends. It might make them interested in ecoenzyme.
Oh yeah, I can put ecoenzyme descriptions, the danger of organic trash, and how to make ecoenzyme in it. I can also put molasses, fruit, and candies inside the kit too.
Exactly. You can share it to social media too.
You're right. I'll post it in Bahasa and English so I can improve my English. Hello, Mom? Oh, okay, Mom. Sorry, my mom is here, so I gotta go. See you. I'll definitely try to make eco-enzyme.
Bye-bye. Any small steps can make a difference to our environment. So don't forget to collect organics, make eco-enzyme, and help our earth to be a better place.